So, all right, cool. So I might go back and remake one for linear equations. That way people in the future have it. But for right now, let's move on to solving linear equations. So when we're solving linear equations, I don't I don't remember if we talked about it last time when we're solving for a slope, but in this lesson, we will learn how to do multi-steps for linear equations. So it's not so simple as like one step or another. We're going to do a few of them. So again, let's try. They're going to have us solving them for one at a time first. And of course, they're going to give me the answers because why not? First things first, guys, whenever you start off, you kind of want to start by, give me a second. You want to start by circling your like terms. If you don't want to circle, that's fine. Just remember that they're different. So here I'm saying, what's 12x minus 7x? So how many x's do I have left? So if I combine these two, I'm going to have 5x's left. And because I have 8 positives and 10 negatives, this number is bigger, so I'm going to be left with a negative number. And that's going to be 2. So my answer is going to be 5x minus 2. That's usually how I remember it. A lot of people don't make this mistake. A lot of people think that whole like positive and a positive is a negative, or positive and a positive is a positive, a negative and a negative is a positive. This is only for multiplication. So when you guys are thinking about positives and negatives, picture like, oh, I have these positive x's and then I have these negative x's, and they're going to cancel each other out. So if you have more negatives left, then your answer is going to be negative. That's the way to think of it when you're adding. When you're multiplying, they're different rules. All right. And then this one, it looks complicated. I don't want you guys ever getting scared of fractions. Fractions are just division and multiplication at the same time. So all we're doing here is we're just dividing. So think of it like here we have 17 thirds. So we're going to have like a bunch of these pies added together. This one, we're going to have like 2/3 taken away. So in other words, what's happening here is there's 17 of these thirds. We're only going to take away 2 of them. So because they're being divided by the same number, we don't have to worry about it. We're just like, okay, it's out of these thirds, we have 17 of the thirds. This has 2/3. So in other words, we have 15 thirds. And there were x's, so we put the little x. That's all we're doing. If the bottoms are the same, it's okay to go and just worry about the tops. So from here, 15 divided by 3, that's just 5x. 15 divided by 3, that's 5. If you don't believe me, or if you're doing this on your own and you need help, always, I actually recommend the Google calculator. Like if you don't have a calculator at home, the Google calculator has quite a bit of stuff. Like I think I even use the Google calculator for the pre-calculus class I teach. Like it has everything. So it's a pretty useful calculator, and you can do a bunch of steps in it. Like let's say you want to do why didn't anybody say anything? Can you guys see? No, thank you. I'm sorry, guys. I get that all the time where I forget to click the share screen button because I have to do it for every appointment. So I'm just assuming I'm already sharing it. Um, so what I was saying here was I already did these problems on X's. I guess if you want to rewatch that, you can go on the YouTube video. What I was saying here is we have a bunch of these thirds. So as long as the thirds are the same, everything's being divided by 3. then it's okay to just subtract the top. And then from here, we can do 15 divided by that. And what I was saying before was, if you guys ever have doubts, you can just go on Google and type in calculator. Four. And this calculator actually does a bunch of stuff. So if you're doing this, you can actually do like multiplication and subtraction and all this stuff in one go, and it will work out it works out pretty well. I recommend doing everything step by step, because even though I think this does PEMDAS really good, sometimes there's issues. I've tried using the Desmos calculator. I'm not a big fan. So far, the Google calculator has been really good. So if you don't have a calculator at home, you can use the Google calculator. But, oh, I forgot. 15 divided by 3, we got 5. So that's how we get this 5x. Then we're going to have, we're going to pretend that there's 17 of these positives, and there's 15 of the negatives. So they kind of cancel each other out, so we're just left with 2 positives afterwards. I'm not drawing all of it because it would take me forever to write all of the 17. So we're left with 5x plus 2. Is this making sense, everybody? I did not realize you guys were all typing that I wasn't sharing the screen. I'm sorry, I got really involved in this. But now that I'm sharing the screen, everything good? Cool. So the next one, we're going to have negative 12 and positive 7x. So we're going to have, we're basically just subtracting. Whenever they're different, think difference. I don't know if you guys remember your keywords, but difference means subtract. So if they're different, we're going to subtract. 12 take away 7. So in my head, I'm always like, well, 7 is 3 away from 10. Plus 2 more is 12. So we're 5 away. But there's more negatives than positives, so it's a negative 5x. So if you can just picture 12 negatives and 7 positives, we're going to be left with those 5 negatives. And then we're at this and this. So there's more negatives. I should use different colors. I'm sorry. We have more negatives than positives. So in this case, 8 minus 10 is going to be negative 2. So this one's going to be negative 5, negative 2. So this exercise is basically just teaching us the difference between positives and negatives. And obviously this will be the last one. This one does have a little bit of work, so I kind of did want to get into that one. So it's negative 9 over 2x and negative 1 over 2x. These are the same, so they're both the halves. If we take away 1 half from 9 halves, we have 8 halves. And 8 halves, again, we're taking it away. So we have 10 negatives. Sorry about that, guys. I forgot that we're adding a negative. They both have negatives, so we have 10 negatives altogether. 10 negatives divided by 2, that's just negative 5x. Is that making sense with the fractions? I don't ever want you guys afraid of fractions. So if you guys are still struggling with fractions, again, don't be afraid to make an appointment with me and we'll talk about it. Fractions aren't anything to be scared of. It's just a different way of thinking about numbers. So now we're going to talk about equations where we set equations equal to each other. So if we have a certain equation equal to another equation, we're going to be able to solve for the x. These are known as linear equations. The reason why they're linear is this idea of y equals mx plus b. It's this idea that this is the rate of change at which x happens. So if we have an x, like let's say we have x is hours and our y is money, then this M would represent how much money we get every hour. So we're going to input like hours in here, and after we like add this and multiply by this, we're going to figure out how much money we get at the end. So that's what linear functions are. It just means that it has a constant rate of change, meaning that, like, for example, if you get a job, you get paid dollars per hour. That's your rate of change. The rate at which how much money you get changes. All right, so now we're going to do solving for one variable on one side. So in other words, all of our x's are here, and we have this. So this one, we're not really comparing anything. It's like, oh, if I do something for X amount of time, and then I do something else for another amount of time, combine them, then we're going to figure out how to figure out the x's. So here, so addition property is literally just that. If you add something to both sides, if you take them away, then it's the same thing. So basically, if I have 5, or this example says, if I have 12 on one side and I subtract 4, then it's the same thing as subtract. So basically what's saying is I have this 12 minus 4 is equal to that, this 8. So in order to get rid of this negative 4, I can add 4 to both sides, and I end up getting 12 equals 12. That's all it's saying. Whatever you do to one side, you do to the other. That's what all of these properties are. So the subtraction property, same thing. Subtraction property says if you subtract from one side, you have to subtract from the another, and it keeps it equal. Multiplication, same thing. So if you're multiplying by both sides, so if you're dividing, again, fractions, in this case, they're even showing it like a fraction. That means you just have to multiply. So all fractions are division. So if you're ever scared of a fraction, just remember you're just dividing. Here, again, if you divide, so we want to get rid of this times 5, we can just divide by 5 on both sides. And you could have done this with the 7 also. They just decided to go with the 5. Did that make sense, guys? Cool. So like terms are this idea that our x's are the same. It's the same thing, same variable, same everything. One thing that people get confused on would be something like this. The reason why this doesn't work, like this is 7a and this is negative squared, exponents mean you're multiplying. So let's say I had something like 7a plus 2a squared. Some people think like, oh, they're a's. These are like terms, so that means it's okay to add these two. You don't, because remember, this a squared isn't an a. It's not 2 times a. It's 2 times a squared. And the reason being is we have to do our exponents first. So we would have to multiply first. So don't think of this as like terms. This isn't an a. This is 7a plus 2aa. They're not the same because it's a times a. So just be aware of this one. I see a lot of people confuse these. And another thing people get confused are when one has a variable and the other one doesn't. You cannot add these because they are not the same. Same thing with these. If they're different letters or different combination of letters, let's say I have 2x, y plus 3x. These are not like terms because this is getting multiplied by y, and this one is not getting multiplied by y. Coefficients is another word we talk about. Coefficients is a number in front of it. It's what we're being multiplied by. Constants just mean no variable. So whenever you think constant, just think no variable. There's no multiplication going on. That's why it's called a constant. So when we're doing this, they're showing us how to solve it step by step. First, we're going to do our like terms. So they're going to combine these like terms. Then they're going to use the subtraction property to get rid of this. You can see it right there. From here, they're going to use the division property. They use it as a fraction. I'm okay with you guys thinking of it as dividing by 6. I think it's weird that they're using a fraction. Although this does come in handy when you have something like 2/3 x equals 9. The reason why this is useful is you can multiply by 3/2, and this cancels out. But another way of thinking about it is, if that seems complicated, you guys can always do this. I'm going to multiply by 3 first, because this is 2 divided by 3. That cancels out. So now I have 2x, and then I can divide by 2. It's literally the same amount of work to cancel it out as doing this. You're just doing it in more steps, and this is less intimidating. So whether you choose to do it with one fraction or in 2 steps, either way is okay, as long as you understand that you're doing the opposite. Does that make sense? Grab this. Cool. And that's pretty much it. So theirs is weird because look, they're doing a fraction, but then they end up just dividing anyway. So that to me is weird. I don't know why this step is necessary, to be honest. But they end up getting to the same idea anyway. All right, so moving on. So unfortunately, they put all the answers in here, but our idea is always to combine like terms. So that's what they're doing here. We're going to go here and we're going to go like, oh, I'm going to combine these like terms. And then here, what we're going to do is we want to get rid of this 7 now. We want to get rid of the 7 so we can eventually get this x by itself. So always remember the goal, guys. Our goal is always to get this x. How do we get the x? We want to get rid of this -2. Well, before we get rid of that -2, we want to get rid of this -7. So we have to work our way into the circle. So we're going to add 7 first. So that's going to be using the addition property. I never know which one they want to do it. To me, addition and subtraction property are the same thing. I'm going to say addition because we're going to add to both sides. I really hate how they call them different properties. Addition property and subtraction property are the same thing in my eyes, guys. So if you're doing a test and you accidentally put down addition property and the test said subtraction property, let me know and I can review that for you and see what we can do. So I'm going to say addition because I think that's what it wants. And then from here, we're just going to add them together. So let's just go over the answers. They're just simplifying. So that's one step they didn't talk about. Simplifying is this idea that, again, we're going to combine like terms and simplify. So these is like, in my eyes, like terms and simplification are the same thing. So there are going to be some cases where they get too nitpicky. That's why we're taking a cohort so I can walk you guys through it. This one, we're using addition property, but then we have to simplify it till we get to this step. And then here we just use division property. Does that make sense? Everybody good on that one? Cool. All right, so moving on. Now we're going to do it on both sides. So if we do it on both sides, again, oh, I really like this picture. This tells me that these are even. So this is how I think, this is what I picture. I don't always picture, but this is how I think of an equal sign. It's a weight. Whatever you take away from this side, you're going to have to take away from this side. Otherwise, the weight becomes unbalanced. So what this tells me is that if we cancel out one of these y's, and we cancel out 3 of these 1s on both sides, Uh, 3 of those ones. This tells me that 2 of the y's equals 1, 2, 3, 4, equals 4 of these, which will eventually tell me that every y represents 2 ones. So this is how we know how to solve this. What I did was I took away 3 from both sides and I took away y from both sides. So that's like a visual representation of how to solve two things. So let's go and get into it. So here, again, they're talking about fractions. If you guys are afraid of fractions, let me show you a cool little trick. So I'm not sure if you guys remember the idea of lowest common denominator. It's this idea that we're finding the lowest number that these two have in common. So lowest common denominator, lowest common multiple, whatever you guys want to call it. It's this idea of like, what can we multiply these two denominators by in order to get a small number? So if I'm doing this, I'm doing 2 times 1 is 2, 2 times 1 is, or 4 times 1 is 4, 2 times 2 is 4. Oh, wait a minute. They match up. So this tells me that my LCM is 4. So what I'm going to do, I'm just going to multiply everything by 4. So this makes this 12 over 2p, because I'm just multiplying the tops, remember? Minus 28, 28, plus 4 times 5 is 20 divided by 4. 4 times 5 is 20. 4 times 7, I have it memorized, but if you guys don't, you can always use the calculator for it. The reason why we're multiplying by 4 is this makes it easier to just divide and just get rid of all of our fractions. So 12 divided by 2, that's 6p. This is supposed to be a p. This is supposed to be a p. 20 divided by 4, that's 5p. 20 is just 20. 28 divided by 4, that's just 7. So this one, it's kind of difficult to visualize, but what I'm doing is I'm just multiplying the 3. So I'm doing this part, and I'm leaving the bottom the same. And finding the LCM made it all the fractions go away. So that's one trick to getting rid of all the fractions, is multiplying by the LCD or LCM, however you want to call it. Did that make sense? I know that one's a little tricky, but there's more than one way to do it, guys, if that didn't make sense. But was that kind of clear? Or do you guys want to see the other way? Yeah, it makes sense? Okay, cool. Let's see how Edmentum wants us to solve it. So Edmentum says, hey, let's change the bottom. We're going to find the LCD and just make everything the LCD. So they're like, we're just going to make it 4. So they're like, so in order to change this 2 to a 4, we're going to multiply it by 2. And from there, I'm not going to lie, sometimes that is easier to do, because here we have 11 over 4. But now we're going to have to subtract fractions. And that gets a little complicated. In this case, not so bad, because we are dividing by 4 on both sides. When we get to this point, they want us to do the addition first. So they want us to do the constants. They want us to add the numbers first. So they want us to get rid of all constants, put all the constants on one side, so all the numbers without variables on one side. And then on the next step, they're going to want us to put all the variables on one side. And I feel like they skipped a step here. They did. They skipped a lot, actually. What's happening here is they forgot to put 4p divided by 4 equals the 12. So this would be p equals 12. So they did get the answer, but I feel like they forgot to do the simplifying, even though they were stressing simplification. So let's get on with this. So now we're going to get into the activity. So this activity, let me unanswer it. First things first, what are we going to do to get this done? So what is all this? How do they want us to do this? Are they just saying which? Lily solved the problem, the explanation or process, select the text that has an error. Oh, okay. So we're supposed to find the error. Well, we already know it's this one, but let's get into it. So to get from here, she's going to add 3x to both sides. So that's why this is right. That one's okay. We're looking for the wrong answer. This one, they're going to add 10 to both sides, so that's right. And this one's wrong because she's subtracting. So that's why this would be considered the wrong answer, because they're dividing. They're not using the subtraction property, they're dividing 6. So that's why the subtraction property would be the wrong answer in this case. And right here, it shows you how you would solve it. So again, here, the way I like to think about this is the idea of crossing stuff out. So if I wanted to write this out, I would write this out as I have 2y's plus 3 equals 1, 2, 3, 4, 4y's plus 2. So from here, I want to get all of my constants are these, over to one side. I'm not a big fan of negative numbers, so I'm going to make sure when I subtract, I'm going to subtract to get a positive number. So now what I did was I'm just going to take away two of these. So as you can see here, I have one of these left. Now what I want to do is I want to take away these two from here. So I'm going to take away 2y, take away 2y. So this tells me that 2y's equal 1. And then from here, I'm saying that every y is a half. So one of these y's equals half of that, half of the numbers. So they kind of drew the y's a little big, so don't always rely on the size to represent how big a number is. So when we're doing this, it wants us to create an equation. So that's what I did first. 2y plus 3 equals, where's my equal sign? Equals this 4y plus 2. 4y plus 2. And that's all they wanted us to do. They just wanted us to make an equation. The next steps, it's like, all right, so how many kilograms? So this is saying how many y's is this? So these ones represent kilograms. So how much does it weigh? Well, we already said from the work I did that should be equal to half. It equals a half. Did it submit? Oh my gosh. There we go. Half. And you can see that by all of this work, or like I said, you can kind of cross it out. And when you cross it out, you're left with that 2y equals 1. So that's how you get that 1/2 for y. And then again, guys, just explain, since you guys are studying in the cohort with me, just explain what you didn't understand and everything in here, what you're having trouble with. If everything made sense, then awesome, give yourself a 5. And just let me know if there's anything you think I can do to make it better. Did everyone understand how to do that task? Yep. Okay, cool. So summary, again, guys, I always stress, make sure you're studying the summary. You might even want to take notes on it, just so you remember how to do everything on here. Having an example does help you out, so you can always have this example. make sure you're kind of writing the steps as they go along too. So for example, the first one was like terms, so you're going to write down like terms. The next one was addition property, so they did addition property, then subtraction property, then that. Write them alongside. It really helps out. Other than that, did anyone have any questions on this? Everybody good? No questions? Now's the time to ask. Nope. Cool. All right, guys. So what I'm gonna do is, for those of you who haven't added this, make sure you guys add this. Again, I'm gonna set the class is meant to be a pacing. So if you guys are behind, like you haven't gotten a 70 or higher on your assignment, uh, make an appointment with me. We can talk about it. We can see what we can do to get your grade up. Because remember, we need to get 70s to consider that unit mastered. I know Edmentum doesn't consider it mastered, but 70 is at least what we're looking for. So add it on here just to keep track of the pacing, and I can always go back and make assignments with you guys or make appointments with you guys. You can always send me an email. My email should be here. Is it not here? My email is not here. If you ever want to email me, though, guys, you can just go on the classroom, go on here and just click my name, I believe. I guess you can't do that. So let me fix this right now. I didn't realize I didn't have my email on here. So my phone number's on here. My appointment links is on here. If you need to shoot me a message, uh, Okay, so now if you want to shoot me an email, it's there too. I probably honestly respond better with texts because what it is I'll keep like a Google Voice tab up here. So I'll see the texts or the reminds better because I usually keep my remind and Google tabs on this screen. Let me stop sharing. Let me stop recording.